I'm going to call this meeting of the Public Utilities Commission to order for Monday, November 2nd, 2020. One day to D-Day, or E-Day, I should say. So please join me in the Pledge of Allegiance. I pledge allegiance to the flag
of the United States
and to the republic for which it stands, one nation,
and to the republic for which it stands,
liberty,
one nation,
for all.
under God, indivisible, liberty and justice for all.
Well, that was excellent. It's a good thing we're not a choir and we all have to sing together at the same time. That's all I got. All right, first order of business, public input. I don't see anybody on the screen with us. Correspondence, nothing other than what was in the packet, right, Kath? Okay. Minutes then. I'll call for a acceptance of the meeting minutes of the meeting of October 19th, 2020.
I'll make the motion, we accept them.
Second.
All right. Any discussion or changes, comments?
No.
Hearing none, I'll try your minds. Those in favor signify by saying aye.
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 And that would be Rich and Paul, and I will abstain. Moving on to financials. We have, I think we just have some invoices to approve. So I'll put a motion on the floor that we approve the invoices dated November 2nd, 2020 in the amount of 2 items from Attorney Martin Waller in the amount of $540.50. Is there a second? Second by Paul. All right, any discussion? And hearing none, those in favor signify by saying aye.
Aye.
Aye, that carries. Nothing under new business. Tom, I'll turn it over to you for director's report before we get
Okay,
into the main issue here.
Just a couple of items before we get into our capital project update. I think, Kathy, we'll be ready to show the spreadsheet of Plumtree's pump station. I had put together showing some flows from 2019 and then some flows after we did the pipelining project in 2020. So let's see how this works. Okay, so what you see here, real quick, I got the 2019 flows, total gallons, and the gallons per day for that month in 2019, January through December. And then next to that, I have 2020. So really what jumps out at me is from about June through the middle of October. The monthly flows are down. They probably would be offset by summertime, groundwater levels drop off. So you would think there would be less flow anyway. But what I added on the right-hand side was our water usage for 2019 and 2020. And what I'm trying to show there is since about March when COVID really hit, we started seeing some increased water flows really kicking off in the month of June. So on the one hand, we had a lot more water flow going on in our system from June on, but it didn't correlate to additional sewer flow. It was reduced sewer flow. So I thought that was a good trend there.
What do you think accounts for that increase in flow?
On the water side, I think everybody being at home since the drought and the warm weather, and people just being at home for those for all those months. I think it was seen across the board with the industry. Every water utility was showing, substantial increases in water demand.
Yeah.
And then of course we had that dry spell and water demand, people watering lawns basically.
Okay.
Well,
Hey, Tom?
Yeah.
If I'm looking at that right, just use January, for instance. We pumped in 2020 4,130,000 gallons. Is that how you're reading that?
Yes. Divide by 31 and there's your average gallons per day.
Okay, but then over on the water use, is that per day or is that?
That would be for the month. That would be million gallons in that month. And it's, again, that's our system wide. I don't have the ability to equate only what's going on in plum trees. I'm just trying to show the trend in water usage. But that would be million gallons for the month.
All right.
That's all. I just wanted to illustrate the flows. That's all.
Okay,
All right.
thank you.
Did you have anything else on your report this week?
Yeah, the one other item I was tallying up, and Kathy, we could, yeah, you can off that. Thanks. I tallied up the dollars spent on our Greenwood Avenue water main break under the railroad tracks. Still not complete because we have to do the final paving. That's the last item to be done. But to date, I've tallied up $162,573 on that episode.
Wow.
So I know, Rich, you had been asking about that.
Yeah.
And I don't have an estimate on the final paving, but obviously we're going to have to, pave that to the state specs.
Cool. Well,
So, they're not cheap. Anytime you're dealing with a railroad crossing, I think Marius can attest on some other projects. The cost involved with doing a water main crossing is pretty substantial.
wow.
But those are my two items on director's report.
All right. Any other questions for Tom?
Yeah, when do you plan to pave? This year or next year, those spots?
We have time still to do it this year. Kelly, have you heard from the rep from the state as far as him wanting it done now?
No, he hasn't questioned any of that. He questioned a service leak. We had at 51 Greenwood. That's what his calls to me were. I guess the permit never got done, so we've got to send a permit off to the state for that service job. And of course, he's going to want a permanent patch in there. But no, nothing yet regarding the railroad crossing.
Okay. All right. Any other questions for Tom before we move on?
No,
All righty. Going on to old business then. I guess this is an item from last meeting, the proposed, the design proposal from Weston and Sampson for continued sewer improvements, sub area 14. Tom, you want to just explain that one real quick?
Yeah, correct. That's the next proposal from Weston and Sampson, sub area 14. This work would include the next two sets of construction plans and specs. There were some questions on the language in the agreement, and I jotted down Marty's comments on those. Went back to Weston and Sampson with those. They made some adjustments, and at this point, I'm looking again for an approval for that design proposal. Marty, I think, commented that he was okay with them, but I don't want to speak for you, Marty, if you have anything else.
No, I don't have a problem with the changes that were made. We're all set.
Okay, well then I'll entertain a motion to approve the proposal from Weston and Sampson.
what's the amount?
It was $50,000.
Oh, that's right. Okay.
And you may want to add the dated October 27th of 2020. That's the latest revision.
Okay, all right, so I'll add that to the, all right. Did you make that motion, Paul?
Yeah, I'll make that motion.
Okay, is there a
I'll
second? Second by Rich. All right, any further discussion on that?
No,
That's not to exceed.
50,000.
Right,
Correct.
Okay.
right, any other comments?
No,
Okay, hearing none, those in favor signify by saying aye.
aye.
Aye. Any opposed? That motion carries. Thank you very much. Item number 2 under old business, 155 Greenwood. Tom, I think this is just an informational thing, right?
Yeah, I think so. I just wanted to comment on two items. It is in the TOD zone. It's before P and Z at this point. Our sewer allocation plan requires PUC approval on anything exceeding 2,500 gallons per day. What they've proposed at this point is a total of 8,965 gallons per day. That's with the mixed use of 18 one-bedroom apartments, 2,200 square feet of retail, and a 200-seat restaurant. So according to our, allocation program, they used the flows we're requesting and came up with 8,965. At this point, I don't know that that their plan's going to get revised. It may. So we can either table this and see what comes in before the at the next meeting, or go ahead and allocate the 8,965.
Yeah, Rick, go ahead.
I'd table it.
I'll second that.
Okay, okay, so we have a motion on the floor to table, and I agree. I know there was a public hearing last Tuesday, and based on the feedback, I've heard that they're going to come back with a smaller scope to that project anyway. So I think it's prudent to table it. So we have a motion on the floor. Any further comments about that?
I know this is beyond, it's not in our purview, but I keep on saying the number of apartments and the number of commercial establishments, there's not enough parking. And to, the thing is that the bank next door, I know, would not appreciate people parking in their lot, neither would our library, because when our library is open, that lot is usually pretty full. So I think there's a problem that the planning and zoning has to address.
Yeah. You're not the first person to make that comment. That's true.
I did have one other issue related to the project, again, for informational purposes only. So Matt, I don't know if you want to finish voting on your motion. I just wanted to bring up one item related to the water main.
Go ahead.
No, go ahead, because it's going to be germane to the project anyway. So go ahead.
Yes, it will. And what they've proposed, which is a good thing, is a water main across the property tied in at both Greenwood Avenue and School Street. So it would loop the system. It would provide a double feed, which is good. The one problem I have with it, and which they will have to address, is the location of the main is right on the property line with the adjoining property of the bank. So in that case, we would need not only an easement from the applicant, we would need an easement as well from the adjoining property owner. And when I put my comments together for P&Z, that will be what I will point out to them. And I just wanted the commission to be aware of that.
Okay. All right. Any other comments?
No.
Hearing none. So we have a motion on the floor to table. Those in favor?
Aye.
That carries. Item number 3, capital project status. And Tom, I think you're going to cover a couple things, then turn this over to Marius for the Bergstrom.
Yeah, that's fine. I could handle the other projects first. It'll only take a couple of minutes, and then we'll turn it over and we can discuss Bergstrom.
Okay.
On our Chestnut tank project, the water main has been installed up to the tank. It's been tested, both pressure tested and disinfected, and has passed. At this point, there's a couple of key items we need finished, which we're waiting on in order to be able to fill the tank. There's a check valve that's supposed to be I think delivered this week that needs to be installed, but more importantly, the electrical service needs to be installed in order for the instrumentation subcontractor to complete their work and to give us the ability to basically control the system and operate the system automatically. So that's kind of where we're at right now with the tank, waiting on Eversource to get the electric service, and then instrumentation can follow next. I don't have a time frame on that. I'm anticipating, from what I've been told, in the next week or two, but that may be hopeful at this point.
Okay.
On 2019 water mains, the water main has been installed on Oakland Heights. It's been disinfected. The next step there is going to be to install the services. While they were waiting to get the main disinfected, they switched gears and went over to Grassy Plain for paving, and they're currently there now. And I believe their next step is going to be to continue paving on Highview, I think, before they go over to Oakland Heights. So, but things are moving along on that project as well. Next up is the Eureka Generator. I spoke to the contractor. He's still waiting on delivery from the the generator manufacturer. So I don't have a date on that one yet. And on the Briarcliff pump station generator that's been installed, and it went through its first weekly exercise on schedule and as programmed. So we're good there. The last item was the Bergstrom well. I distributed the preliminary report from Wright Pierce at the October 5th meeting. And I gave a brief summary of and an overview of that, and wanted to have Marius on board to give a little bit more of a presentation on that for everyone's information. And with that, I will welcome Marius to proceed.
Well, wait,
Thank
we
you.
were going to have a brief quiz on the 155-page report, right?
That's right. I'm going to be asking some questions. Yeah. Well, I hope everybody had a chance to at least briefly look through a report. It's very complex, a lot of information there. But I thought I'd put a little presentation for everyone today, maybe make it a little bit easier to understand. And, there's a lot of technical stuff in the PowerPoint presentation. I'm going to try to go quickly through that. I'm going to pause on each slide. And if the commissioners have any questions, you can ask those questions as I'm going through the presentation. I'm going to try to share my screen now. See if I can do this. Let me know if you can see it.
Got it.
Okay. So you should see the first page of the PowerPoint presentation, the title page. So again, thank you for having me today at the meeting. This is a summary of the Bergstrom well water treatment plant preliminary design engineering report. Let me just go quickly if I can see if I can advance the slides here. Yeah. Okay, here we are. So just the presentation overview. I'm going to talk about the project background a little bit. Some of the water supply requirements set by Connecticut Department of Public Health. I'm going to compare the cost of the upgrades to the existing water treatment plants, the Eureka and Chestnut Ridge. And then I will go back a little bit to talk about the CIP plan that we developed in 2014 and the cost spent today by the town. And then I'll go into the alternative analysis for the Bergstrom well project specifically. So again, just a project background. So as the commission can remember, in 2014, we've completed a capital improvements plan. And one of the recommendations from that plan was to explore a new groundwater supply to replace the Eureka Lake and the Chestnut Ridge water treatment plant. So just to remind everyone, the Eureka Lake water treatment plant was built in 1970s, has a poor water quality, there's taste and odor issues. The reservoir itself has very low safe field, so very little water is available during a drought condition. Only it's 0.33 million gallons per day. No major improvements were made since 1970, since the plant was constructed. And since that time, the plant was operating, on emergency status. It was basically supplementing the water to Maple Avenue wells, but right now it's off. All the water is coming in from the Maple Avenue well field. In 2014, we estimated the cost to upgrade that plant to be basically $3.1 million. And then when you escalate the cost to bring it to the 2023 year, which, when the Bergstrom well will be online, the cost is basically $4.81 million just for that one plant to upgrade. Similarly, the Chestnut Ridge water treatment plant, was built in 1909. So again, it's a very old plant. The building was last upgraded in 1970. Again, has similar water quality, TTHMs. The reservoir has very low safe yield, only 0.17 MGD. So again, it's very little water available during drought condition, and that's what the state is looking at. They're looking at how much water you have available when you have a drought, when there's no rain coming in. Again, those reservoirs are very small. They have a small watersheds. So again, that's the key factor, which I'm going to talk about later in the presentation. And again, the estimated upgrade construction cost that was estimated in 2014 was, again, 4.1 million. And then when you bring it up to the 2023 year, to make it equal with the Bergstrom well, it's $6.36 million to upgrade that plant. So now, in 2014, we basically set on a new path to look for a new groundwater supply. So we found a nice source of water in the Bergstrom field. So the well was installed and permitted in 2019. The well has a very high safe field and capacity of 1.152 MGD. So this is equivalent to 800 gallons a minute. So basically, the one well feed would replace your Maple Avenue wells. You know, each Maple Avenue well is doing 400, so that's about 800. And then, again, the cost that we estimated right now, it's 7.67 million, and brought back to 2023, and that includes contingency, 20% contingency for that project. However, that would supplement, and provide redundancy to replace your treatment plants, but also supplement water to the Maple Avenue wells. But we found some iron manganese in that source water. So iron manganese treatment is required to be able to run that plant. Just to show you, we talked about some of the, the demand in town. So this shows the water demand going back to 2010. As you can see, since 2010, 2020, the water demand has been increasing. It's been going up in town. The 2020 demand, it's not complete. This is through September, and you can see the average day demand was 1.21 MGD. And again, this is something that Tom alluded to. A lot of people were home. They were using a lot more water due to COVID condition, but you can see the average day demand was, 1.21 MGD. The maximum day demand on the maximum month in the summertime was 1.35 MGD. And I guess the maximum day demand was 2 MGD. So, again, that demand has been going up. In Bethel is growing. There's new people coming in. So now, why is this important? Okay, so Connecticut DPH requires water companies to maintain a safe field, a margin of safety on your safe field of 15%. So what does that mean is basically the available water in your water system from the reservoir's groundwater divided by your water demand in your system has to be greater or equal to 1.15. So they want you to maintain a 15% of margin of safety to be able to provide adequate supplies to your customers. Okay, and the available water is directly related to the safe field of reservoirs and the treatment capacity. So, safe field is how much water is available from a source under a drought condition. So these two tables now, they compare your existing sources. So table 1 on top here shows the safe field of your existing sources as they were calculated and approved by the DEP and DPH. So as you can see, under the existing conditions, without the Bergstrom well online, the safe field is 1.66 million gallons per day. Now in table 2, you can see I removed the two surface water. So I removed the Chestnut Ridge Reservoir treatment plant and the Eureka Lake water treatment plant. I left the Maple Avenue wells intact, and I added the new Bergstrom well. So you can see your total safe field, it goes up from 1.66 to 2.312 MGD. So really the Bergstrom well already adds a lot of water to your system that otherwise you will not have available from the two surface water supplies. And then this table 3, it basically compares, the margin of safety. So the margin of safety, as I indicated, is calculated by, the water available divided by your demand in your system. So here in this table, in this upper portion of the table, it shows the water demand in your system from 2010 to 2020. This shows the available water. So this is your safe field under the existing conditions without the Bergstrom well. And this is a margin of safety calculated for your average day demand. So you can see under your average day demand, that ratio is higher than 1.15. So under the average day demand, you are able to meet, the margin of safety under the Connecticut DPH requirements. Then if you move over here, this is then the state wants you to look at the maximum month average day demand. So again, under the same scenario, you are able to meet, the margin of safety existing supply. And then if you look at your maximum day demand under, a summer condition when everybody's using water, here you're actually getting, in 2018, you were getting close. So it's 1.16. When 2019 and 2020 actually, exceeded, went actually less than 1. So what does that mean? For example, in 2020, basically you had the two sources, your Chestnut Ridge was off, and then the Eureka Lake treatment plant was off. So you were operating the Maple Avenue wells at the stress condition. They were basically pumping probably more than they were designed to pump to provide that water during, during that time. So the table below over here, it shows basically the same numbers. However, I removed the safe field from the reservoirs and added the safe field from the new Bergstrom well. So as you can see, here you actually have much higher numbers, margin of safety numbers, these both numbers. If you look at this last column over here, you can see that you're meeting in 2020, in 2035 and 2065, you're gonna be getting basically, below the 1.15. So when we were starting the Berkshire Well project, you can remember we're aiming to get about 900 gallons a minute from that well. However, throughout the tests and all the analysis, we found that the well can only produce 800 gallons a minute. So you're still gonna be 100 gallons a minute short. However, where you can actually meet the 1.15, you can meet those numbers through a water conservation like you've been doing. You've been trying to restrict water use during summertime, during peak demands. I know Kelly's been sending out notices. There's a lot of in-ground sprinkler system in town that people are using during peak hours. So again, these numbers, you're not meeting them here, but I think you can meet them throughout basically doing water conservation and limiting how much water people can use on those really, really hot days when you're stressing your system. So again, here, this table kind of summarizes. I talked about the estimated costs for the surface water treatment plant upgrades here. So this table shows, the 3.1 is a 2014 number. Those numbers in parentheses are numbers projected out to 2023. And this table basically shows equivalent number to treat 1 MGD, okay? So you can see, the message here is that, both the Eureka Lake water treatment plant and Chestnut Ridge, they cannot provide the water that you need, and the cost to upgrade it would be much higher than the cost compared to the cost of the Berkshire Well, which is going to be able to provide you the safe field that you need moving out to the future. And DPH is actually very stringent. They want you to project your safe field and water demand for the next 50 years. So every 10 years, they require water companies to update their water supply plans. So at that time, we usually update, the water usage, the water projections moving forward. So again, this table kind of shows, that, really, you're only getting, 0.5 MGD from the two surface waters, and it's gonna, if you do a cost per million gallons, like almost $34 million to really treat that water, to treat 1 MGD from those plants. And when you compare the cost of the Berkshire Well, you get 1.152 million gallons per day. So it's about 6.65 million gallons. So really, I know there's a question raised, how come, can we upgrade our, surface water treatment plants? Yes, you can, but after the upgrade is going to be very costly, and you're not going to get as much water as you're going to get from the Berkshire Well moving forward. So even if you do those upgrades, you will still need to look for additional water supplies because you're not going to meet your safe field in the future. So again, just some pros and cons very quickly. If Berkshire Well is not constructed, you're going to have to make upgrades to the, Eureka Lake water treatment plant, Chestnut Ridge water treatment plant, very costly. You're still not going to be able to meet your margin of safety, and additional supplies will be needed. There'll be no backup or redundancy to the Maple Avenue wells. You're probably going to continue to do the annual redevelopment of the Maple Avenue wells, because again, as you remember, last year they've been pumping very hard, 24 hours a day, 365 days, a year, that they've really been working very hard to produce that water. So if you continue using those wells like this, there's going to be loss of capacity will continue coming up. And then if the Berkshire Well is constructed, then, obviously we'll provide a backup to the Maple Avenue well, so you can alternate operation between, the two sources. Berkshire Well provides an increased safe field to your system, and Novo maintains a safe field as required by Connecticut DPH. And then, the cost of construction will be less, on what per 1 MGD basis when you compare to the upgrades to the other plants. And then you guys did a wonderful work. The CIP was done in 2015, and you really have done a lot of really good projects in town. So this kind of shows from that report is, when we did the report in 2014, we basically recommended the short-term improvements between 2015 and 2019 to about $14 million. That's how much we recommended to be upgraded, in the short term. The intermediate term improvements, they're basically $10 million. And then the long-term improvements, $61 million. So there's a lot of work that, needs to happen to your system, but you've already done a lot of work, and your major components are already in place after just 5 years. So I think if you move forward with the Berkshire Well, that's going to be basically a last major project then the battle is going to have to undertake, to really be able to provide adequate water supplies moving forward. So some of the projects that were completed, Eureka Lake Tank, $2.5 million, the Hoytsville Pump Station, $1.3 million, the Berkshire Well exploration and permitting, that was $300,000. The Chestnut Ridge Tech is under construction, $1.9 million. The South Street Pump Station, $650,000. The Briarcliff Pump Station, $750,000. Again, all these projects, you've done a lot in the last 5 years. If you add it all together, that's about $12.5 million that you guys already spent in the last 5 years on the major projects in town, which will really bring, the system forward to the next century. So again, the last upgrade is really the treatment plant, because you need additional water. So that'll be pretty much the last major upgrade that you have to undertake to really, make the system work and, really address a lot of the issues that Connecticut DPH, was raising. So again, just a little history. I'm not going to spend a lot of time on these slides, but again, the Berkshire Well was installed in 1919. 800 gallons a minute flow. We got all the approvals in place. However, there was iron manganese found, so we need to provide treatment. We've conducted the alternative analysis report that was provided to the town in 2020 September. So again, just quickly, Connecticut DPH has requirements for iron manganese. It's 0.3 action level for manganese, and then iron is 0.3. In the Berkshire Well, the levels of manganese we found was 0.388 milligrams per liter. It ranged from 0.349. So again, you basically have to treat to remove manganese. The same thing with iron. We didn't anticipate that we're going to find iron manganese. We thought that the water quality is going to be similar to the Maple Avenue wells. Again, Maple Avenue wells are located in the same aquifer, very close, and we don't have those issues. Here, we actually found iron manganese that needs to be treated. So again, I'm not going to really go to a lot of details to these technical slides. So this just, without the pilot testing, we're able to prove that, the Greenson Plus is going to be able to remove iron manganese from your wells very good. You're going to get good removal rates, and the process is going to work. Again, we've talked to manufacturers, recommended three filters to be able to remove water and treat it to the levels that you need. There was some other equipment included in the report: backwash pumps, recycle pumps, chemicals. You have chemicals for disinfection and orthophosphate for corrosion control. There's going to be electrical instrumentation needed for that project as well. So we talked about recycle of the supernatant. So once the flow is treated, there's going to be a backwash generator. So there's a couple options for that backwash. I'm going to talk about it more on the next slide. You can recycle it, or you can send it to the sewer. So I have some costs to kind of illustrate, how much money you might be saving by recycling that. And I know that it seems kind of unreasonable to be able to backwash backwash your flow that you treated. However, DPH and EPA allows it, so they allow you to recycle 10% of your flow. So if you're going to be pumping that well at 800 gallons a minute, you're going to be able to recycle 10% of 800, which is 80 gallons a minute, back to the plant. This is like about 27,000 gallons per day. And you can see this picture on the left. What it shows the settled supernatant. So the very dark stuff on the bottom is the heavy stuff that's settled after 5 hours. So this heavy stuff would not be recycled. This heavy stuff will be basically sent to the sewers, but the stuff on top will be recycled and mixed with your raw water coming from the wells. This is done almost everywhere. It really provides a lot of cost savings. It saves you water because you don't need to send this water to the sewers. If you didn't recycle that water, you'd be basically wasting that water going out to the sewers, and it's widely acceptable. We've conducted the pilot testing, and the pilot testing concluded that, mixing that backwash is not going to impact your finished water quality. So we would definitely recommend recycling option for this project.
So Marius, you're blending 10% recycled water with 90% raw water.
That's correct.
And that's what you're putting on the filters to filter.
That's correct, yes.
And when you pilot tested that, your irons and manganeses?
They didn't change at all. They were pretty much the same levels. There was no jump, there was no increase. So we feel very confident that, that the recycling option is going to work.
Marius, what is the sludge at the bottom? Now, you said you could put it into the sewer.
That's the iron and manganese. That's the sludge you can put in the sewer. Yes, you can pump it out to the sewers, or you can actually, have a pumper truck take it out and take it to a wastewater treatment plant.
Okay, I have another question here. I shouldn't put my chemistry hat on, but I will. The filters, how expensive are they? How often do they have to be?
Okay, so the filters, the package for the filters themselves, I think we got a price that's included in the report. I think they were like maybe $230,000 for the package for the filters. And then, the replacement's really not that often. Depends on the.
Can they be backwashed?
Yes. So
Okay, and the other question I've got is, you said the initial cost for Bergstrom was something like $665 per million, I think. Does that include the filtration?
Yes, that includes everything. That's the entire treatment plan, everything that you would need. Yes.
And then, I'm looking at this whole complex thing. Will this plant require a specialist to operate it?
No. I mean, Ed is already licensed as an operator. You wouldn't need to have any additional certifications. Those plants run automatically. You don't need anybody to be there. There's going to be SCADA, there's going to be alarms, and they're basically just, they're turnkey plants. They've been installed everywhere in New England. There's a lot of installations in Connecticut, Massachusetts. There's a lot of water systems that have groundwater supplies with iron manganese issues. So this technology is very old, very, very old, and it works very well.
Okay.
Paul, our licensed operators would be operating that, and they get their license through the state as water treatment plant operators.
Yeah. Well, let me just throw this back to Tom. Then how many operators do you plan to have?
We anticipate having the same number of operators that we have now. Like Marius described, the plant does not have to be manned. It's going to run off of controls like most of our other, systems.
Yeah.
And the backwash cycle is automated.
How often does the backwash occur?
Well, basically we set it up, I think, so that you can backwash it at the max flow about once a day.
Okay.
So I think we'd probably work our schedule around, being there, around the time the backwash is occurring.
Okay.
So you're essentially running one column at a time?
Pardon me?
What do you run, one column at a time?
Oh, Dino, go ahead.
Yes, when you backwash, you run one filter at a time, yes.
When you backwash, it's one filter at a time.
Yes.
How many are online?
When you're online, you go through all the filters at the same time.
Okay.
So then they'll backwash in sequence.
So is always two online, one backwashing?
That's correct, yep.
Marius, let me throw another question
Sure.
for recommendation to the commission here. What are we going to do with Eureka and Chestnut? Because I look at Eureka, that reservoir, I would say it has quite a few acres of water in there. And I assume it's reasonably deep. What do you recommend we're going to do with it in the future? I know you said it'll be expensive to upgrade it, but certainly it's not going to go away. It's going to be there for us. So what are your thoughts?
Well, I think right now you keep it online as emergency only, go into the future and see how you're doing with your next water supply for an upgrade.
Yeah.
You have to look at the water demand, water usage, and your Maple Avenue wells. And it's getting older, it's not getting younger. So eventually things are gonna start breaking up. Right now, Ed keeps it going and it's working well. There's some issues right now that haven't been. Keep it online for a few more years and then make a decision then. I think it's good to hold on to it because you have a diversion permit you can use it. You have a permit from the state. So I think right now I guess if you decide to put the Bergstrom online, you keep both the Chestnut Ridge and Eureka online for a little bit longer, and then you can make a decision then.
Yeah. Is there something that you would say that we should really look into just for long-term usage that's not too expensive?
You mean for the building time? I don't.
No, for both of those reservoirs.
The problem, Paul, is you've got to meet the safe drinking water.
I know they're requirements, but is there something that I just don't want a surprise, say 3 years from now?
Well, as Marius was describing, and as my thoughts were, the day that you get Bergstrom online, I don't think it would be prudent to then say, all right, we're going to abandon the surface supplies. I think, again, the approach would be, let's hold them in reserve. They would be listed as emergency sources, because really, once you have a source of water that's approved as a public water supply source,
You don't want to give up.
you don't want to give up. It's actually a process. The health department would probably be pretty strict in even allowing us to give that up, because they would want to make sure with certainty that it's no longer needed as a supply.
No.
So I think going forward, you got to keep it. You see how your new system, your wells are operating. You have that as reserve, as an emergency supply if ever needed.
Yeah.
And going
Well,
forward, you kind of make a decision from there.
I would assume that we would say we would, on a monthly basis, we would, maybe I'm wrong about my thinking here, that we would use perhaps anywhere from 2 to 5% per month of reservoir water. Would that be an error?
I think we would want to basically make sure that we are running water through both of those plants to make sure that they're disinfected and they're not.
Right, right.
Whether you put them in service or you run that little bit of water to waste, it really, if the reservoirs are on standby and they're not really being used, then you're not really wasting your supply system, but you're
Right.
at least keeping the water moving. And then it comes down to really, if you want to put it in the system, it comes down to water quality.
Yeah,
Taste and odor, THMs, and that's kind of the issues that we have with these, which is why we've been looking for an alternate source for these last several years.
If we want to keep them as emergencies, do we have to do any investment?
Well, that is a good point, Dino, and I would imagine there would be some discussion in that regard with the health department. I don't think they're going to let you keep them forever as emergency supply without doing some kind of upgrade. And maybe it's whenever you use it, you're in. I don't know. There may have to be restrictions on its use at that point, but I think it's an unknown at this point.
there's no law stating that we can't mix, is there?
No.
Okay.
All right, I got a question, Maris.
Sure.
How much water are we putting into the sewer per day if we pumping the 800 gallons
27,000 gallons
per day?
Per day,
Would go into the sewer.
right?
Yeah, I think the numbers were, Rich. We would backwash about 30,000 gallons. So if you held back the 10%, that'd be 3,000.
Okay, yeah, I'm sorry. Yep. Yeah.
The 90% would be the 27,000 gallons. You could then, over time, and again, you can only recycle it. If you're doing 800 gallons a minute, you can only put it back into the system at 80 gallons a minute. If this system was only operating at, say, 400 gallons a minute, and Maple Wells were operating at 400 gallons a minute, then the 10% of 400, you'd only be able to recycle it back into the system at 40 gallons a minute. So the bottom line is, they restrict you to 10% for water quality purposes.
All right, I'm sorry, I'm not following you. I understand about the 10% recycling, but what is the amount that would go into the sewer each day at 800 gallons?
So if you recycle the water, you can recycle the entire amount. You can recycle 27,000 back to your system. So daily would go 3,000 to the sewer on a daily basis.
Only 3,000.
Yes, if you recycle, yes, yep.
Where does the 27,000 gallon a day number come from?
That's from the backwash. This is how much water is required to backwash all the filters, Dino. So this is the water that's needed to basically backwash the filters, to get them clean again before the next treatment cycle.
Okay, because 80 GPM times 1440 is clearly a lot larger than 27,000.
I think the 27,000, you got three separate filters. And Marius, you can correct me if I'm wrong.
Mm-hmm.
You got three separate filters. There's a certain amount of time that you backwash each filter at a certain gallon per minute rate.
Mm-hmm.
So when you calculate out, and I don't know what that number is off the top of my head, if it's, let's just say it's 1,000 gallons a minute for 9 minutes, that would be 9,000 gallons.
Right.
So that's basically what you're doing. You're backwashing it for a certain amount of time at a certain rate, and you got three filters. So that's where the total of I think it's 30,000 gallons for the day, Marius.
That's correct. Yep.
So again, if you recycled slowly back into the system, the 27,000 gallons, you'd be left with 3,000 gallons that you really can't recycle. That would be discharged to the sewer, I would say, on a daily basis, or maybe on an every other day basis type of thing.
That 3,000 gallons is primarily the sludge at the bottom.
That's correct. Yes.
And is Danbury capable of taking that?
It's pretty liquid. We're calling it sludge.
It's
really
1%,
very-
1 to
it's very
2%.
liquid.
It will be diluted by the sewer in the water, and it's done commonly with other facilities. They go to sewer. We will have to get a permit from them for discharge of water treatment, wastewater, and it's commonly done. So
When you say a permit from them, you mean from Danbury?
Danbury, right?
Okay.
Well, I think it's a state permit. It's probably a deep permit.
Right,
Department of
right.
Environmental and
DEP, but
Energy.
they have to sign off on it
They
again.
have to sign
You know,
off.
I mean, it's gonna be diluted so much because, you know, it's gonna enter your system, it's gonna go through your sewer, it's gonna go to, you know, pump station, you know, that's a big wet well there, so it's gonna be diluted very much before it gets to Danbury.
Tom, what is Danbury's water flow? Do you know? Their sewage flow?
I want to say, Dino, don't hold me to this, approximately like 9 million a day
Oh, so this is like 0.03% then.
on an average day. Oh, yeah, absolutely. And they'll have heavier days as well. I mean,
Sure.
Okay, let me move on to the next one here. So again, you know, we've considered in the report, we've considered 4 different alternatives. You know, again, I'm not going to go to a lot of details for each of the alternatives. You know, the site that we picked was the Bergstrom well site. You know, we've looked at the other sites, Whittlesey Drive, Judd Avenue, and Maple Avenue Wellfield. You know, again, you know, cost-wise and, you know, and operational-wise, the Bergstrom well site, you know, basically was the winner for the analysis. Let me quickly go through it. So again, this is would show you the, you know, this is the Bergstrom well site right here. This is the Bergstrom well. This is Plum Trees Road. So, you know, there's an access road coming through here. So, you know, we would propose to construct the, you know, treatment plant right next to that well, you know, with a generator. So there'll be one generator to power the well and power the treatment plant. We would have to construct a finished water line. This is the green line that would connect to your existing water main here on Plum Trees Road. And then you would be able to pump to your distribution system. So again, this is, you know, a low pressure filtration system. This would pump directly to the Eureka Lake zone. It would go to the Eureka Lake tank. The South Street pump station will pump to the Chestnut Ridge zone as it's doing right now. You know, the estimated construction cost $7.67 million. You know, the O&M is $173,000. Again, you know, you're already spending money in the Maple Avenue wells for the O&M. So if you're going to be using the Maple Avenue well less or half of the capacity, you know, again, some of the savings would come from the Maple Avenue wells and we go towards that well. So, you know, the O&M is really, you know, you can't say as the 173 is all extra cost. You know, if you're going to be, you know, running this well and the Maple Avenue off will be off, obviously you're not going to be incurring any O&M costs from the Maple Avenue well field. You know, all the O&M is going to come from here. If you're going to be running the Maple Avenue half capacity and you're going to be running this well at half capacity, you know, only half of that cost, you know, you're going to be incurring. So it's not a straight add-on. You know, you're going to be saving some money, but not running the Maple Avenue well so heavily. You know, you're basically going to be splitting that cost moving forward. So again, you know, we thought that this was a nice location. It's far away from all the schools, from all the residents. There's no one there. You know, it's nicely separate. It's close to the well, so you can have one site. You know, when you send somebody there to service the well or the treatment plant building, you know, it's one site stop. He doesn't have to go to separate sites. You know, there's nobody around. Very quiet area. You know, we felt like, you know, this is probably the ideal location for that treatment building. You know, again, as far as the cost is concerned, also the cheapest alternative moving forward.
and I'll just mention the other 3 potential locations are all in the report, and they spelled out the pros and cons of each of the other sites, which I'm sure you guys have had a chance to take a look at. If not, please do look at that report, and you could see what the pros and cons were for the other sites.
So again, that's the site B, Whittlesey Drive, you know, be located right here. You know, again, there's a lot of information in the report on that. You can, review it, or, we can discuss it now. If there's any questions, I can stop on each slide. But we did look at alternative sites just to see, what might be the different options and, the best way for the town to proceed.
Maris?
Yes.
Why is the cost of operation and maintenance, O&M costs go up when you move to a different site?
Because this other site includes pumping to the Chestnut Ridge zone, which is the higher zone. So
okay.
you basically your horsepower of your pumps goes higher. So basically the electric cost related to pumping to the higher pressure zone, because you got higher horsepower motors and everything else.
Okay. Thank you.
Sure. So yeah, that's another site, Judd Avenue. Again, it's, right within the school complex. And again, we were looking at the properties where the town already owns the land. We didn't want to look for properties where you have to purchase the land, because that would be the additional cost. So again, all those sites consider, properties that are near the well, relatively close to the well that town already owns. We don't want to, look for a vacant property that, you're going to have to spend additional money for. So those are the ones that are typically close to the well, but again, very close to the school complexes. You're gonna have chemical deliveries. It's probably not really a good spot for the treatment plant building there. Then you're gonna have to run additional water main. The length of the water main is gonna be higher from the well. You're gonna have separate generators. So there's a lot of different things that really bring the cost much higher than comparing to the site A. And then, we've looked at the Maple Avenue well site as well. This was one of the things that, the state wanted us to consider again. You're going to be spending a lot of money just to run the water main from the well site, from Berkshire Well all the way on Plantrees Road to this well site is going to be very expensive. Even looking at the construction here, you're going to have these wells operational. It's really going to make it very hard to operate the Maple Avenue wells if the construction was going on that side. And again, the cost is very high, because you got to run, basically raw water main to that site, which is very, very long. It's over 5,000 feet. You need separate electrical stuff, just going to cost a lot more money there. And then, we talked about, there's a lot of questions about, I'm sorry, go ahead, Rich.
Just back to the Bergstrom site there. Are we in the floodplain? The building would have to be raised up higher and everything?
Well, we actually, outside of the 500, 100 floodplain, we found a little area in there that, is going to be outside of the flood zone. So the building right now, again, we need to do a detailed survey, Rich. But, we, based on the FEMA maps, looks like we're going to be outside of that flood zone. We might have to do something with the road. I know that the road, when it really rains very heavily there, I think the road floods sometimes. There's a stream going across the road. So we might have to look at the road, if the road needs to be raised in case, it's not the entire road. It's a small section of the road. Whether, if you needed to get to that site during a flood event, you might have some water on the road. But, again,
Is that included in your cost?
That's included in our cost, yes.
Okay.
So again, we talked about, the backwash disposal. I'm sorry, someone had a question again? So yeah, we talked about the backwash disposal cost. So again, this slide kind of shows we've calculated based on your current flows to Danbury and how much you're paying. We've calculated, the cost, how much you pay if you decided to not to recycle the flow. So, basically, if you do not recycle, if you're going to send all the backwash to Danbury, you'll be basically looking at about $25,000 a year to basically pump the flow to Danbury. So that's about $500,000 over a 20-year period. If you were to recycle the flow, which we highly recommend to recycle the flow, you'll be basically paying about $2,500 a year for that flow to Danbury. So it's not a lot of money. And I think by recycling, you're really saving a lot of water, and then you saving your cost disposal to Danbury. And then just, yes, this project is very expensive. We didn't anticipate we're going to have iron manganese. We hope that, the water quality will be very similar to the Maple Avenue wells. It's very close to that, draws from the same aquifer. So again, we've done a lot of these iron manganese plants as a company. So, we've seen a big increase over the last 10 years 10 years ago, you can build a 1 MGD plant like yours for about $3 million. Now it's more like $6 million plus for 1 MGD. There's a lot to do with, building code changes, requirements, there's fire protection needed for like chemical storage and things like that, cost of labor and materials increased. And then, the final cost, it really depends on your building itself. Our cost estimate in the PDR is basically a basic building. It's a slab on grade building. The backwash tank and the backwash supply tanks will be outside, generator outside. So it's basically very bare bone cost, based on our previous project, just to make sure that we keep the cost of the project low. There's different options. You can have a treatment plant building that has, basically like the backwash tanks and the clear well inside the building, or they could have it below the floor level, but that really increases the cost because again, when you have a multi-level buildings, that it's really a lot of excavation. We know that the groundwater is very high in Bridgeton Well. So that would really, that would probably make that project, close to $10 million or more if we made it like a multi-story building, if everything was inside the building. So right now, this is again, it's a slab on grade metal building with 2 exterior tanks, one for backwash storage and one for backwash source water. Again, our estimate, is trying to keep the construction costs very low. And again, I think when we estimated the building could probably get a little bit smaller. So we're going to work, if we move forward with this project, we work closely with the town to try to, obviously, reduce the construction cost of the project. We feel there's some still, ways we can make the building smaller. Right now, I think we're showing 60 by 70 in our PDR. Again, everything's based on size. If you make things smaller, it's going to cost less money. So again, this is a preliminary report. As we get into the design, we're going to try to, work with the town and Tom to try to make it, cost effective and, even reduce the cost a little bit more if possible. So again,
based upon 2020 dollars.
Well, the cost is based on 2023. Yeah. So we escalated when we put our estimate together, Paul, we estimated the cost into like the 2023 dollars. So this is escalated forward to account for any inflation and increase in cost and everything else.
What was your inflation rate?
The inflation rate, we look at the ENR index, which is the building index. So, in our estimate, we use 5%. Again, it's based on, the increase in labor costs, material costs, the wood, because everything's going up every year very heavily. So, 5% is a good number. So I think, if it's less between now and then, that'll be even better for the project. But we want to be conservative, make sure that we have enough, budgeted money for the project moving forward.
On those external tanks, given our weather, how do you insulate them for the winter?
They'll be partially buried. And what we've done is you basically put like a little insulation on the outside, and there's always going to be movement in those tanks. Both tanks are 40,000 gallons, so they're not really small. There's going to be a lot of water in this. They'll be partially buried. And then, they're going to be mounded. So there's going to be earth on top of them, but they're also going to be insulated from the outside.
Okay.
Meredith, when we get to that point, I'd like to see some sketches of how the tanks look on the outside of the building versus if we put them inside the building.
Absolutely. Yeah, we'll do alternative analysis. We're gonna have workshops, with Tom and his staff, and also we can invite, whoever wants to participate, from the PUC in those workshops to discuss various design options. That's definitely, we like to get, our clients involved in all the projects to make sure to get input on, how all those things get done. So.
Yeah, Marius, since it's a steel building, I can tell you we've had experience over at the recycling center with our highway department where the bottom is rust out. And the recommendation by the individual at the time was to, elevate it with concrete.
Right. I mean, I think what's going to be very important, Paul, is really the HVAC system, because you're going to have, water sweating in there, and there's going to be a lot of, condensation potentially in that building. So you're absolutely right, Paul. That's something that we can take care of using, HVAC, proper ventilation system to make sure that room is dry. Again, your car garage, there's probably, the doors are probably open all the time, so because the trucks are coming and going out. So it's definitely, a different environment here. Here we're going to really, ventilate and, put an HVAC system to keep that inside of the building dry. there's not gonna be that many, visitors on a daily basis, probably just, maybe once a day or even once a week. People are gonna be coming in, so that's something that we are aware of some
Good.
issues with the metal buildings, and we're gonna take care of it. So good questions, Paul, thank you.
All
So again,
right,
just-
I see that was my next question was coming up is your next slide here. It's gonna, from the beginning of design and permitting phase to construction is 2 years?
2 years, yes, and this is very conservative, Rich. This includes, review by DPH, review by the planning and zoning. Again, we can try to accelerate that, but we've allowed for review time for the town by the town, the bidding and everything else, and the winter shutdowns. Obviously, when they put the building up, they could work in the winter because they could work inside of it. But again, you're gonna have to, we're gonna have to design it. It's gonna have to go out to bid. Then the town's gonna have to have a referendum approval. So that includes all the different town meetings that the town's gonna have to have. It allows for all the permits and things that we need to get from the local planning and zoning, from the DPH. It reviews all the design periods and everything else. And and we don't know who we're gonna get for the contractor. So this is kind of estimated, for an average contractor, how long would it take to build this?
Yeah. Okay.
It could be quicker. It could be quicker. Again, I don't want to, put something here that we're not going to be able to meet,
Yeah.
Rich. Want to be realistic. If we can beat this schedule, I'll be very happy, but I don't want to be short on your project.
Yeah. It's been a long time coming. It's
Yeah,
gonna be a while.
So what this also shows is, I like to schedule a site visit to a similar facility. So we have a client in Meriden that has a similar treatment plant. So, he suggested some dates. Again, I like to do it sooner than later because this presentation, the report is fresh in everybody's minds. So I guess, he suggested a couple of days. Tom, I don't know if you have my email. I could try to pull up my email.
I do. I have the dates here. So,
Okay.
yeah, looking at this, I mean, the first two items there, I think are the ones that we need to kind of work on here in the very short term. Get a site visit scheduled, and then I think the commission, the Public Utilities Commission, should approve the report to enable us then to go ahead and submit it to the State Health Department for their review and approval. So I don't know that everyone's going to be available for the site visit, but the first date he threw out at us is actually next Monday, the 9th at 10 a.m. And then at this point, he's thrown out two other dates. Unfortunately, they would both be after the next PUC meeting, but it would be Thursday, the 19th at 10 a.m. And I think it's Friday, the 20th at 10 a.m. So I'm not sure how much flexibility they have. Obviously, Marius has been in touch with the town of Meriden as far as their availability. So we're kind of subject to, basically meeting them on their schedule. So I'll throw that first one out there to see if, we're able to make that the site visit date and time work. So we're looking at November 9th, next Monday at 10 a.m.
Let me, before we go to that, Tom, let me ask another question.
Sure.
What's the commission's pleasure? Are you ready? Do you feel you're comfortable approving the preliminary engineering report to go to DPH now, or do you want to do that site visit first?
I think we need to study it a little bit more.
Okay.
Yeah, and I'd like to see the site visit too.
Okay.
Yeah.
All right. I am not going to be available on the 9th, but I can make my own arrangements at some other time. So I would encourage everybody else to go whenever it's possible, hopefully before the next PUC meeting.
Yeah, unfortunately, the next meeting we would have is the 16th.
Yes.
I assume, well, we could, if we wanted to, if the commission, would like to have the next meeting on the 23rd as a special meeting. That's a possibility, I suppose.
You can do that.
Yeah,
And then that would give us 3 dates to possibly have a look at the other plant.
All right. Well,
And before we hone in on that, Marius, would it be possible for us to have a site visit on more than one of those dates?
I could ask, yes, possibly. Yep, I could ask. Yeah,
In other words,
definitely.
split us up if
Yeah, maybe in
possible.
2 groups. Yeah, I can definitely ask. Yep.
I can't speak for them, so I don't want to really assume that.
Yep, I can ask.
But if we move our meeting to the 23rd, then that gives us all three of those dates are prior to our next meeting. I'll just throw that out there.
I'm good on the 16th as long as it's in the morning. We can do it early.
All right, well, the dates were the 19th and the 20th, Matt, besides next meeting of the 9th. We got the 9th, the 19th, or the 20th.
Yeah, the 20, I'm having eye surgery, I think, on the 20th.
19th, I'm good. 20th, I'm not good.
Okay,
So I got 16th and 19th.
Oh, 9 or 19?
9 or 19 at this point, Dino. Matt's good for the 19th, not good for the 9th.
I'm good with both the 9 and 19.
Okay,
I'm good for the, I'm
the
good for
ninth.
the, go ahead. Go ahead, Rich.
I'm good for the 9th.
I'm good for the 19th. The 9th is 57 years here in this house.
okay, so Matt and Dino and Paul, we're all good for the 19th. Do I have that right?
Right.
And Rich, you're not good on the 19th?
I gotta look, see when I have my surgery.
Okay, is that something you can get back to me with?
Yes, I will.
Okay, because that would be great if you're available the 19th. I think we can make it all for all of us on that date.
Okay,
And if not, we'll at least ask the question to see if they can maybe host us on the 9th for a couple of us and the 19th for the rest of us.
okay. I'll give you a call tomorrow
That'd be great.
on my schedule.
Okay,
Okay, well, that concludes my presentation. I don't know if there's any other questions at this point.
Can you email that to us?
Yes,
Yeah, I was
absolutely.
gonna ask the same thing. Yeah, good idea. All right, perfect. All right, thank you, Marius.
Thank you.
Thank you, Tom. We're gonna move on, utility supervisors report. Kelly? Anything?
Okay, I've got a few things. We've been discussing that bladder tank up at the top of Briarcliff. Marius had looked into some information. We're looking at between a 30 and 50 gallon bladder tank to put in there in size. My thought is it could be put in a 2-inch meter pit right there on the right of way where we've already got a tap, but we are working on that, trying to come up with different options. We did find a service leak up there today on one of the houses at 25. It's up by the tank site, but it's on her property. So we're meeting with her tomorrow to get that repaired. The past couple of weeks, there's been some paving done. Judd Avenue was done. We had a main break there it was probably a year and a half ago, and American Paving came in and repaired the road there, as well as Milwaukee, where we did main work there about 3 years ago. It started to settle out, so that's been repaved. And Grandview, when we switched all the 2-inch services over to the 8-inch transite main, that was paved from end to end. So those are all taken care of. I was at South Crossings today, inquiring about what lots are left in there. There's only 2 lots that don't have foundations in there. I'm gonna guess that Toll Brothers will be out of town on those 2 projects. I'm gonna guess by the springtime. They're moving right along, and yeah, they're all but one is permitted. We've got meters in all but probably about 4. So that's moving along pretty well. As for up at the tank site, that extra work that you guys authorized, it came in, the labor and the material and machine time came in at $73.75. It was $1,000 to do the wet tap. And I don't have the parts bill in front of me, but I'm pretty sure it was $4,300 or $4,400. So we came in under $13,000 to do all that extra work. So you guys had authorized us with 15, and we stayed in there pretty well. And it was a job well done. The only thing I don't like is the hydrant that they used is sitting pretty high, but it's all that I had in stock at the time. So at a later date, if it doesn't work out, then we'll change it out. But I like the idea of the high hydrant because it distinguishes against the hydrant that's only up there for flushing. As for hydrant repairs, I talked with a contractor today. He's been in the hospital the past week, but he basically told me, give him a list. And the CBYDs, I'll put them in place. And he's going to get at least half of them out of the way. There's only 6 that I'm really concerned with. Like I said, 2 of them are part of our main extension for next year. So there's really no saying, and our main replacement, excuse me. There's really no sense of doing anything with that. Other than that, everything's pretty much status quo. I do have an issue at Paul Street, though. If you remember last month, I was telling you that we had issues with the generator there. So I had HO Penn come in. It's a cap motor. They had their specialist on generators come in. As I explained last month, we were having a foam issue coming out of the breather when we lost all the power there about a month and a half ago. Well, we checked the oil when HO Penn was there, and it was overfull by quite a bit. So he took a pump and he went into the bottom of the
Oil
crankshaft or the crankcase, and there's water in there. There's water sitting in the bottom of the engine itself. So bad thing right there. His technician thought there might have been a problem with the oil cooler, but this technician that was out there, he's basically his boss. He looked at the radiator. He looked at the sludge in the radiator. His thought was to do the oil cooler and the radiator. It's about $7,500, but that's basically a crapshoot because there's still somewhere this water is getting from the radiator into the engine block. So his next thought was a long block. If they come, they pull the head, they find issues, long block is going to be between $35,000 and $40,000. A new engine is between $80,000 and $90,000. And that's not even including the rigging. You're going to have to get Mariano's to come over and pull that out of there. So Tom and I have talked, we're going back and forth a little bit. You're still dealing with a 25 to 30-year-old power plant. I'm pretty sure that was in the early 90s when that generator was done. The original generator is in the basement of Wall Street right now. But again, we're still dealing with an old power plant. It needs a new voltage regulator, which is about $3,000. The parts are obsolete. They have to put an electronic unit in there. So I started talking to this guy from HO Penn a little bit more. I said, listen, he says, that generator is oversized for what goes on in that plant right now. That's a 350 kW generator. That was when they were actually treating sewage and putting it into the system. This was designed when it was a true treatment plant. Now it's basically a glorified pumping station. So he had suggested that we get a hold of the past year's bills and also have like an electrical engineer come in and figure exactly what we need to power this. And I think we were just shooting from the hip, and we thought that this building could be powered with like a 200 kW, which he thought that would be half the cost of a new engine to be able to put in this plant. Now, we've already got a slab there that Mariano's could come over, take that whole system out of the way, put it on the slab, and we've got I think it's a 500 gallon, or maybe it's a 1,000 gallon oil tank, above ground tank, double insulated, that we had got a real good deal on. I think we can put this whole unit right on the pad. So what I'm basically asking you is your blessings for us to pursue a replacement on this generator. It's very important. This isn't the type of right now we've got the temporary generator from Eureka down there, and that's tied in, but that cannot pump 2 pumps at once if we had to. We relatively always pump with only 1 pump anyway, but it would be maxed out. The only thing in our favor, we're not using air conditioning this time of year because the air conditioner has to be on in that building. So again, what I'd like to do is get your blessings to pursue what it's going to cost to replace, and also pursue what size we need what they usually recommend is they figure what your building needs and add 20%. I guess that's the rule of thumb. And again, this was just one contractor. This is H.O. Penn. H.O. Penn is very high on what they do, but I do agree we need to pursue a new generator. I would go to Kingsley. I would go to, I can't think of the other one that does Cummins engines. Anyhow, there's 3 or 4 people. Who would it be?
Well,
I would like.
There's several different vendors. Northeast Generator, there's
Cannondale.
Kinsley, Cannondale.
I want, to be honest with you, I don't think I'd want to go with Cannondale because this is a little bit above them. I mean, they treat me very well. They're right there when I need them, but this I think is going to be a big
Right.
generator.
Right.
You know, I'm going to guess it's
But Cannondale Services are municipal center. That's a pretty big generator back there. You know, I'd like to put this out. I'd like to put this out to bid. You know,
Well, first of all, you got to hire the electrical engineer to tell you what size you need.
right.
Yeah, we're
That's
gonna,
the first step.
Exactly.
And then you can go out to bid, then you can go out to bid for any kind of generator you want. I mean, you put it out to bid. Where you get prices
Yep,
from
no, that's-
3 or 4 different.
yeah,
You
we've got a
gotta
little bit of
determine the
homework to
size
do.
first. That's the first thing you need to do.
We're gonna go through at least a year's worth, or I'll try to get my hands on 2 years worth of the electrical bills, so we can see what the KW was for any given month. We've got a couple of electricians that work for the town that are familiar with generators. We're gonna probably walk through with them and at least get some ideas in terms of sizing. And then I think, yeah, we'll have some homework done to go to an electrical engineer and discuss getting it sized.
Okay.
All right.
Agreed.
All right. I have, either Tom or Kelly, and Meredith, while I see you're still on here, I'm really concerned about that bladder tank sizing for the, Chestnut up there. A 30-gallon tank, we put those in for a single family residence. I really think they should be a larger tank.
Well, it could be a larger thing, but the tank in Hoyts Hill Ridge, I mean, we put a similar size thing, Hoyts Hill, I think it's like an 80-gallon tank. So it's, it's not a lot bigger than what we proposed in Briarcliff, and, that pump station is working very well. Again, that tank was size based, average day demand, and, I think the pumps are gonna do much better. I think Kelly just mentioned today that he found one leak on the service line. So again, if you're gonna repair all the leaks and, that tank, I mean, you have, I don't know how many homes you have, like, you have maybe 12 homes or 14 homes. So really, 30 or 40 gallons should be enough to kind of, reduce how much those pumps are pumping. I mean, you can go with the larger tank, right? You're gonna spend a lot of money, but then, I guess it's, I think with the 40-gallon tank, those pumps are gonna cycle a lot less, maybe every 5 minutes, and, those tanks are meant to be let's say at night, nobody's using any water. So you want your pump station to rest, you don't want the pumps to be pumping at night because nobody's using, water, and so the intent for those tanks is, the water would come from those tanks at night when there was really not a big usage, because right now those tanks are, those pumps are coming on and off all the time because there's no other storage in the system. We can definitely look at the higher, larger tanks. I mean, I know that Kelly wanted to put it in the meter pit, so that would depend how big the meter pit is. But again, in Hoyts Hill, we don't have a much larger tank, and those pumps are already working well there. They're really not cycling all the time. So that's something we can look into it. But
All right. Well, when you say a 30-gallon tank, you're talking about a drawdown of 30 gallons?
yes, drawdown. Yes, drawdown.
Well,
Yeah.
Yeah, but a drawdown of the 30-gallon extra tank is probably equivalent to a 120-gallon galvanized tank. So that tank is approximately probably 3 feet in diameter and 4 feet high. So it's not going to fit in. I agree with you. If your drawdown is about 30 gallons.
Yeah, that's that. Yeah, your usable volume, drawdown.
tank.
Yes. Yep.
The other tank we were looking at, Marius, was that tank that had 53 gallons of drawdown.
Mhm.
And Rich, I think it was a 24-inch diameter by about 45 inches tall.
And they had how many gallon drawdown?
It was, I think, 53.
53, yeah.
So that gave us a little bit more than the 35 that you had come up with originally, Marius.
Yep.
All right, I like to see the spec. Is that like a well troll tank?
It was a, yeah, it was Amtrol, what was it? Well Extrol, I think.
But yeah, well, actual it's the it's a tank that doesn't have has a bladder inside, but it's like it has full capacity. So it's so the bladder doesn't really take up any space inside.
All right, I just like to see the spec on it, Chris.
Sure. And again, I was thinking in terms of ratioing it down from the Hoyts Hill tank, because Hoyts Hill, I'd have to go through and count, but there's a heck of a lot of homes on that system.
You have a lot more main in there too, so you got your water storage in the mains
Right.
too. All right, as long as it's a minimum of 30-gallon drawdown, I'm okay with it.
Yes, that's what it was. Yeah, I
The
think that's what we
50-gallon drawdown's even better, but
right. Well, that's what we
That's-
figured. It's not the size of the tank; it's the drawdown of
right,
available
correct.
water. Rich, yeah.
correct. Because that's the worst thing for those submersible pumps, the on and off all the time.
Okay, so you guys have a plan?
Yeah, I think we do. And we'll put something together and keep going at it.
Okay, all right, that sounds good.
Matt, can I ask Tom a question?
Sure.
Tom, just briefly, has your office calculated what's left on our allocation with the sewer allocation? You keep
Yes,
total of that?
yes.
Well, I'm not, I know it's unfair to ask you now. I'm not asking you now, but maybe if you can call me and let me know.
I can tell you, because I anticipated, what that number, having that number handy today. So, Paul Street, when we put our plan together in 2016, had a bank of 200,000 gallons. Between what we've allocated through, as of today, it's 176,794. So we're
Left?
left out of the 200, yes. So we've allocated, I think it's 23,000 plus in about the 5 years. Payne Road had a bank of 125,000 and there's still 123,700. So not much has been allocated from Payne Road. And Berkshire had a bank of 11,194 and only 80 gallons have been allocated. So it's 11,114.
We're in good shape.
So we're keeping track of the numbers.
Okay, good.
Thank you, I appreciate it.
You're welcome.
All right, I think that's it. There's no other business. I'll entertain a motion to adjourn.
Wait a minute.
Okay,
I think I'd like to get Bob Kozlowski into this conversation here. Just looking ahead, what we're going to be spending if we go ahead with these projects and expenses associated like generators, et cetera. This coming January, I believe we have a 5% increase on water coming through. Bob, you're muted.
No, I see that. I believe that, yeah, we have the final increase.
That's the final
coming in.
one. Yeah. And I think we've got to start planning going forward at looking at our rates with these expenditures forthcoming.
Yeah, Tom's already spoken to Dave Fox, and these are numbers that we can add to the projection, but he's in pretty good shape to come up with some numbers in the next, I don't know, a couple of weeks.
I see, I'm looking always at a 5-year plan and
Yeah.
Correct.
we're at the end of our 5-year one here
Yeah.
coming up.
We are, Paul, and it's actually a good thing that we waited at this point because of the Bergstrom well and needing the treatment.
Right.
That project was obviously more than we had anticipated, over the course of the last couple of years. So I sent Dave, our consultant, an updated spreadsheet. Included in that was the numbers that Marius projected for the Bergstrom well, as well as some other projects that I've tried to project over the next 8 coming years. So he's getting closer, I think, to being able to put something together for us on the water side. On the
Right.
sewer side, I think the numbers that I gave him previously anticipated a larger number from the Danbury plant. Now that they've gone to this design build program, I think their number is a little bit lower, which actually helps us. And, but I'd still really like to get better numbers from Danbury, something in writing from them as opposed to just verbal. So on the sewer side, I think we're still probably wanting to wait a little bit till we get something better. But on the water side, I think we're in a position to, crank in these, the Bergstrom well project and have him put something together for us for an upcoming discussion on a rate increase.
Yeah, I agree with you. I think what we should do is schedule something between this committee for the first quarter of next year. Let's say January, February, sometime around there. Let's take a look at these water rates.
I agree.
And Kathy, would you please put that on for January? Okay, thank you. Old product manager here, 5-year plan.
Absolutely.
All right. Okay, that sounds good.
All right.
Okay, now I'll entertain a motion to adjourn.
So move.
All right,
Second.
by Rich, second by Paul. Those in favor?
Aye.
Aye.
The motion carries. Thank you very much,
Thank you,
everyone.
everybody. Nice seeing everybody healthy
Yeah.
and
See you,
Take
Mary.
care,
Dave,
Marius.
thank you.
Thank you for your presentation.
Sure. My pleasure. Thank you, Kathy, for your help. Bye.
Good night.
Good night.